you could look at it as a death clock as well in reverse, because if you start at like 0.1 methylation, you end at 0.56, 0.57, that's kind of like the death point. With that, because they all hypermethylate with age, unlike time, you may be able to slow it down. You might be able to change it with like lifestyle interventions or drugs or supplements. So you may be able to reduce or slow down that aging process. But at the same time, you could also maybe accelerate that aging process, and depending on how your environment is affecting that aspect.
Chris Collins, what is a biological aging clock?
Okay, so a biological aging clock, and there's many different facets to that, because some people would say, the machines you can get in gyms, they sometimes say they do biological aging by looking at like electrical impedance, body fat. You type in a few questions like, oh, do I smoke? Do you do drugs? Do you exercise, etc.? And there's the other biological aging clocks, which is like one of the things that we do, and one of the things that I've made using like DNA methylation, for example. You could have telomere testing, and there are other types of epigenetics you could also use for biological aging. Now, the key with DNA methylation clocks, like the one that I've made with the University of Essex, is that it correlates directly with age. So the clock that I designed was looked at 850,000 CPG sites. These are like sites across your genome, and they methylate or lose methylation as time goes on. And we found 10 sites that basically hypermethylate, so they gain methylation with age, and they correlate with time. And this was from saliva. In the paper, we looked at about 3,000 people, and now we've probably tested it on about 10,000 people. And all these 10 sites, they hypermethylate with age. So when you're born, you will have a set methylation point, and then as you get to like 80, 90, if you reach that, you will also get to a set methylation point. So you could look at it as a death clock as well in reverse, because if you start at like 0.1 methylation, you end at 0.56, 0.57, that's kind of like the death point. And with that, because they all hypermethylate with age, unlike time, you may be able to slow it down. You might be able to change it with like lifestyle interventions or drugs or supplements. So you may be able to reduce or slow down that aging process. But at the same time, you could also maybe accelerate that aging process, depending on how your environment is affecting that aspect. So the cool thing about biological clocks is that you can't do anything with time. Time has always moved forward at a steady rate, but you can do something about the biological clock. And now there are a couple of biological clocks out there. There are some that use linear regression. That means that the sites are all weighted the same, and they basically all go in one direction. And so like ours is hypermethylation, they go in one direction. Now you can use that model, and then you can apply something called elastic net regression. And that basically looks at the sites that correlate the most with aging, and you weight them higher than the other sites. By doing that, you get a correlation closer to time. But by also doing that, you negatively affect the impact of those smaller sites, which may have some interplay with things like immunity and disease. So if you want to keep that biological aspect in, so for example, if someone has a higher risk of certain disease, if you want to keep that in, it would increase the variability of the clock, but it's more usable from a biological standpoint. But if you use elastic net, it would be more usable from a forensic standpoint. So say, for example, the police wanted to use something to predict somebody's age because they had some sample at the crime scene and they had no idea who the suspect might be. They could use that to then predict the suspect's probably aged between 55 and 60. So, that's quite a powerful tool in forensics. So yeah, there's two types of biological clock.
So I didn't fully get it, but if I understand, you're trying to point out that from a health and wellness point of view, correlation with biological age does not really matter, because it's not like the average 18 years old person has the best capacities of of a humanly possible, right? And the other one is the ACM, the all cause mortality clocks. You see, I want to understand this. So you said there is linear regression and elastic net regression, right? And but what does this have to do with the previously what I just said? You see
So
what I mean?
you can weight certain CPG sites differently depending on what you want to achieve. So, for example, if you wanted to achieve a tighter clock to time, so if you wanted it to basically correlate to chronological aging better, you could use elastic net because you could weight those sites which are would really correlate with time, so they always hypomethylate or they always hypermethylate with time. You could weight those higher in the algorithm, and then you could weight the other ones which have more variability lower in the algorithm. But those smaller ones, they do correlate with time, but there might be a reason why they're more variable. They might be more variable because they alter with disease patterns, such as like dementia or cancer risk. So you may want to keep those the same as the other ones if you wanted a more variable biological clock, which associated more with disease and pathology. But if you just wanted it to have a high correlation to chronological age, you may want to minimize those factors.
So the linear regression model, let's say in PhenoAge, looks like this. You have a biomarker and you have a multiplier, and then and then a big sum of biomarker multipliers, right?
Yep.
So how would the elastic net regression look?
Yeah, so say for example you had 10 CPG sites. Now in linear regression, all those 10 CPG sites could be meaned. You'd get an average methylation level, and that average methylation level would increase with time, hypermethylate with time. That accounts for every single of those 10 CPG sites being equal in the algorithm. Yeah.
Mm-hmm.
If for example 2 of those sites correlated with chronological age better than the other 8, I could weight those higher in the algorithm, give them more purpose in the algorithm to get the correlation better by minimizing the power of the other 8.
And MuhDo is which type?
So MuhDo does both. It predicts age from a linear regression clock, the one that I've published. So that's pure methylation across the sites. They're all weighted equally. And we also apply an elastic net as well if you wanted to correlate to age better. But also we also have certain clocks like memory age, hearing age, and eye age, which use sites which correlate with certain conditions. So, for example, our memory age correlates with dementia, but also with people who subjectively say they have memory loss. And then we apply an age multiplier to that. So it uses both. You can weight CPG sites depending on how they correlate to certain things more in an algorithm to give it more power for that specific point.
Okay, so since we are getting deep into the algorithm, let me ask a question. So I coded PhenoAge, right? And I noticed that there are biomarkers. Those are, let's say, albumin, that if you put 9999999, right, and you're going to get a really good results, even though in reality you're dead at that point. So my understanding is this is because of the size of the UK biobank that they trained it on, and they couldn't find they couldn't somehow figure out where should be some of those biomarkers upper limits or lower limits, and how the curves should be. So, but then again, that's how the linear regression works, right, in mathematics. So my question is, how's MuhDo doing it?
So MuhDo started quite a long time ago now, about 9 years. And we started doing commercial epigenetic analysis with the Epic array, which looks at about 850,000 CPG sites. That's now become 950,000 with the new model. By collecting data from people, we not only collected the sample, but we also collected genotyping data. So we used a GSA, a modified GSA array with more health genotypes on. And we also collected questionnaire data. We collected tracking data. And we collected health data, any medical records, for example, family history. And we also now have like a face scanner thing, so we can correlate to that if we wanted to. And we have like a cognitive game on the app, so people have been playing that as well. And so we have this like massive data bank. And when we started, obviously a data bank was quite small, but when we hit about, 10, 15,000 people, we could then start seeing these correlations between things. And what was key about us is that we used saliva from the start, whereas most companies started with blood and then had to have their blood clock transferred to saliva. Now, saliva is really interesting because unlike blood, it has multiple cell types. So you really need to have a good database to actually make a clock out of it. The reason being is that if you have a certain mix of different cells in your saliva, that could actually impact the methylation status. So the way we do it is that when we hit a certain number of subjects, we basically cause statistical oblivion, if you like. It was averaged out to such an extent that on average, these sites are meaningful. It doesn't really matter across the board. There's so many samples there. So the p-values of the CPG sites that we use are ridiculously tiny. The significance is really high. And that's how we basically build a clock. So to obviously build an aging clock, it was quite simple. We took the demographics of people from the youngest, I think was 11 years old, and to the oldest, which I think was around 94 years old. And we just did the statistical analysis across all those CPG sites to see which ones correlated the highest to aging. And then to build the other clocks, we then added in like, okay, we now know which sites are correlating with age. How about sites that correlated between people with no diagnosis of a pathology versus those with diagnosed heart disease, for example? And what's really cool about that is that we can take in age groups. So we can use a cohort of 50 to 55-year-olds of heart disease, 50 to 55-year-olds without heart disease. And that takes away CPG sites that alter with time, because we know that heart disease will always, increase with time, that risk factor goes up with time anyway. So we need to remove that factor. And we can do that by making these little cohorts. And therefore, we have independent CPG sites which correlate to pathology. And that's how we can then build some other clocks. So we have this new one called HeartAge coming out, and then that one will play into that.
All right. So before we go forward, and I mispronounce the name like 5 or 10 different times, could you tell me where did the name come from, and then teach me how to pronounce it?
So it's MuhDo. You can call it MuhDo if you like. Some people do. And the name actually doesn't mean anything. It was just a unique name because I think a lot of companies went down the whole DNA or genetic route by adding that into their title, which in the beginning I thought was actually a good idea because it made sense. We look at genetics, so let's call ourselves gene something. I think the reasoning is that if it was to become a bigger brand in that field, it needed to stand out and be more unique. And then we also learned that people didn't ever say what they were getting tested. So I heard a lot of people say that they did a test, like it was never a gluten intolerance test that they did. It was a brand name they did. So when people talk about our test, they don't say, oh, have you done a DNA test? They go, have you done a MuhDo test? Or have you done 23andMe? Have you done Ancestry? They're all the same. Actually, the arrays all cover the same SNPs in a way, especially those three companies. But 23andMe uses the GSA, Ancestry uses the type of GSA, and we use the type of GSA. So when it came to genotyping, no one ever said, have you done a DNA test? They just said, oh, I've done Ancestry. Oh, I've done 23andMe. Oh, I've done MuhDo. So it actually stood out for that reason. People talked about MuhDo as a test rather than a genetic company.
Oh, yeah. There is this. It's a big dilemma for anyone who's running a company or creating a company, that should they name after that what they are doing exactly, or should they come up with something unique, something generic that eventually they can put all kinds of different products and services under that name, right? Anyhow, give me an overview.
MuhDo's overview is that we were one of the first companies to offer epigenetics commercially. And we're probably one of the only companies that offer it combined with genotyping, which I think is really key, because the genotyping is that foundation level that you really need to know about, right? and then the epigenetics builds upon it. One of the big companies out there, actually a lot of big companies, they harp on about things like MTHFR, for example, and they talk about this as a methylation test. Oh, do your methylate. Well, it's not a methylation test. It doesn't test DNA methylation. It's a test of a genotype or a gene, in this case MTHFR, which controls the methylation cycle. The same with BHMT, for example. There are multiple genes in that cycle, but everyone became fixated with MTHFR. It's an important gene for sure. And a lot of people do have variants which are important for them to know. But it's not a methylation test. So when people sell methylation tests and they say, we look at MTHFR, they're not testing methylation. We test methylation, we test DNA methylation, we test the methyltransferase connections across those sites that we look at. So that is true DNA methylation. Now, we know that MTHFR is important and all the genotyping stuff is important because it builds upon that foundation. Now, if a gene isn't working from inheritance, mutated from inheritance, it doesn't matter about the methylation so much. But if it is working, like most people's are, you don't have to care about the methylation. Is it hypermethylated? Is it hypomethylated? Is it working not enough, or is it working too much? And so actually it's really important to have those two layers. And we always thought that, hence why every single person who does a test will always have the genotyping test done as well as the epigenetic test done. And obviously from that point, they only have an epigenetics analysis after that point because the genotyping's fixed. So I think that made that was a big difference for us. And then we also wanted to focus on science and research. So we have got a few projects going at the moment. So we work on a EU-funded project called Predictum, which is to do with Alzheimer's and prediction of Alzheimer's. And we're doing the DNA methylation analysis for that. And we've obviously published the first clock, the 10-CpG clock, with the University of Essex. And we're also working on some other projects with them. We do have multiple preprints in different sporting attributes as well. So we look at like injury risk factors and epigenetics, injury risk factors of genotyping. And we've also done some studies with how resistance training and endurance training alter the epigenome and how the methylation changes across the board between two types of exercise. So yeah, we do have quite a few university partners, King College London, University of Essex, etc. We also did an interventional study with a polyphenol supplement to see if that could alter DNA methylation, to see if it would reduce biological aging. We have got a lot of stuff coming up in the future as well that I can't talk about right now. But yeah, I mean, as an overview, we try and focus on getting new stuff out there in the commercial world rather than just sticking to academic, but we try and cross that border, right in the middle of both.
So how many versions do MuhDo clock has right now?
So at the moment, if you want biological aging, you get, if you don't give us any information, so say you don't give us a date of birth or anything, you will get a predicted age, which is that pure biological aging that we spoke about, the 10-CpG one. Then you'll get a memory score, a hearing score, and an eye score. So that's basically those independent sites looking at your risk factors for those three areas. You get a new test that we created called Epivitality. And Epivitality basically looks at your wellness, your robustness, your immune strength, inflammation power, all that kind of stuff. And it's actually a really, really tight clock. There's some papers that are out there at the moment on it. It correlates with fibromyalgia. So people with fibromyalgia get worse scores. It correlates with fatigue. People who are highly fatigued have worse scores. And actually people who are highly stressed over a long period of time, they also cause that score to lower. It's a hypomethylation clock, or hypomethylation score, I should say. And then we have a couple of other ones which are a bit older now. So we have inflammation, we have immunoscore, and we have muscle degeneration. Immunoscore and muscle degeneration are going through a revamp to a new version soon. But basically, they, again, looking at our database, we can see where people are more likely to get injured, for example, for muscle degeneration, like overtraining. And our immunoscores, obviously, if you look at the immune system, how many times are people getting ill throughout the year and stuff, how many colds and flus are they getting? Is it correlating to any methylation change? Inflammation is inflammation. We look at inflammation levels, the genes associated with inflammation, but also people who suffer from inflammatory type conditions like rheumatoid arthritis.
All right, so let me ask the question in another way. Let me bring you something. So I was asking about versions, right? Then my question is, what am I holding here? Do you recognize it?
Yep, so that's a genotyping and DNA methylation test. So when you spit in the tube, you would have one tube in there. What happens is that it goes to a lab. That lab's Eurofins, which you may have heard of. Eurofins are one of the biggest lab providers in the world. And then the saliva in that tube will be split into two lots. One lot of saliva, that's it. One lot of saliva will go for genotyping, and the other lot of saliva will go for DNA methylation.
And this is an older version, I believe, because I brought it home.
The box is an older one, but the test is the same.
The test is the same. Oh, I see. Okay. So it doesn't matter then if I order it from, let's say, MuhDoAge, right? Or I order it from you guys, then you're doing the same malware test.
It does matter to some extent, because if you use MuhDoAge, you will have the older app, the older MuhDo app, because they white label that version of the app.
What does that mean?
So basically, we have white labeling as a service in our company, which means that other companies who don't do what we do can basically make their own brand using our science and our technology. So, for example, GrimAge have, I think it might be a white label. If it's not a white label, you will get a new app, I think. But basically, some companies are resellers, so they just resell MuhDo. And some companies have their own brand, which is built basically on our science. So it's a copy and paste basically of our app, effectively, with their color scheme and their logo, etc. And they might add other things on. So it's not like it's just, you might be paying more, but they might add other things into it. So we have made unique things for white labels as well, which they have for them, specifically for them. I can't remember if MuhDoAge. I think MuhDoAge might just be a reseller. Now, with that kit that you have, you could probably use the code on it and sign up to the most modern app, which is called MuhDo Hub. So if you go onto the Google Play Store or iOS Store, you'll be able to go onto MuhDo Hub, and you can download that app. You can scan that code in, and you can send it off, and you'll get the results on that.
Now, what's the unique selling point of the MuhDo biological aging clock?
So it's unique for a few reasons. One of the unique aspects is that it was built on a database which is non-accessible by public access. So unlike the UK Biobank, for example,
it's from your bank, from your application, right?
Yeah, it's on our application. So we've got a lot of data, and actually more data per individual that some others do. Another aspect to it is that some of the recommendations we have are actually also from our data bank. So we know when people take certain supplements or do certain things that actually reduces biological age, because we can track them, because some people have done multiple DNA methylation tests with us by now. So even though the overall amount of tests that we've done, like DNA methylation tests that we've done, might be smaller than like a big public database, the quality of each individual data set is probably a lot higher, because the amount of data on each person is a lot more in depth. Very big questionnaires, face scanning, GPS tracking, all that kind of stuff is a lot higher. So we can get more in depth about it. And so that's one of the unique aspects, because it's built on that unique data set. And because it's built on that unique data set, we're starting to roll out a couple of other really cool applications and a couple of spin-off companies, if you like, but are using that science. One of them is called MuhDo Fight Hub. I don't know if you've seen that advertised yet, but you can probably find them on Instagram. Now, MuhDo Fight Hub actually has a whole bank of combat athletes as part of it. They have lots of fighters, MMA, all that kind of stuff going on. It's really cool. And we're trying to now tailor certain epigenetic algorithms to that modality. So like combat athletes, for example, athletes in general. And by doing that, we're trying to get the turnaround time of the epigenetic analysis down to about a week. Because if we can do that, we know that there are certain markers that change quite acutely when people go into overtraining and they become at risk of injury. So if we can test people, athletes especially, more often and get that result in quicker, we might be able to say weeks before they become injured, look, you need to slow down, or you might need to change your nutritional habits or diet, or change the way you're training, because in the next 4 or 5 weeks, your risk of injury is going to be skyrocketing. Now, you probably know yourself, and I know myself, injuries, whilst you might feel a twinge here and there when you're training, injuries come out of the blue. All of a sudden, I'm training and then bang, my knee's in agony, and then that's 6 weeks off, right? With this new epigenetic analysis that we aim to do with MuhDo Fight Hub, is actually have a test that we can test more often and tell you, look, your risk of injury is starting to really go up because these genes are changing now, and try and bring that back. And I think injury is one of the biggest bottlenecks to athletic performance. And I really want to try and remove that. One of my first ever studies in 2018, 2017 was actually looking at the genotypes associated with injury. And you can look that up in a journal called Sports. And after that, I did another study looking at DNA methylation in injury as well in soccer players. And again, that's just where this information comes from. But because we can't get the turnaround time at the moment down to a week, it's too late. By the time you get your results, you're probably already injured. So if we can get that turnaround time down, we're going to have a really nice product for the combat athletes, but then all athletes. So we can really start tailoring our type of testing to these different areas.
Yeah, I mean, injury is the biggest, isn't it? The biggest problem for any sport. A couple of questions came to my mind then. Well, firstly, in your paper, you're stating or you're comparing MuhDo to Horvath and Hanum, I believe, if I remember well. And you're saying that it's almost as good, right? But using much fewer CPG sites. So then the question is, why should we care? Why fewer CPG sites? Isn't more the better, or not?
It depends on a couple of things, right? So more CPG sites isn't always better because it adds noise. So by adding noise, you may have signals from certain elastic net regression again. You might have that these other clocks use elastic net regression, basically making some sites more important than others. So you have noise in there, and we've removed that noise on a linear regression level. So we've removed the noise, making us a less markers, but they were all important from saliva alone. So one of the main things is that the other clocks come from blood and they're transferred onto saliva, whereas our clock was built on saliva alone. Because we have less sites, we're actually with Illumina, and we're partnering her up to create a new array where you can do an epigenetic test for really cheap, right? And that's the key here. I want a biological age test that I can track. I don't want to be spending $400 every time I do a test, right? I want a test that's accurate, published, peer reviewed, validated, works well, and is cost effective. And that's the key, right? Sure, if you have all the money in the world, you could do lots of cool tests. Muscle biopsies, why not? You could find out the biological age of your muscle. That's great, right? But most people can't do that. And on a commercial level, it makes sense to create something small and effective that people can then use all the time. I would rather have a biological age test that someone's done 7 times in a year rather than have someone who's done a biological age test at the beginning of the year and at the end of the year. Because I can get all those markers, I can see a lot more data from that than I can from the other two, and that's the same cost, you know. So that's
So
the biggest
the
factor.
turnaround time is faster than other clocks?
We're trying to get that down. So if you get that turnaround time down as well to a week, you're laughing. You've got a cost-effective clock, fast turnaround time. You can really measure different interventions better, right? If you're doing an interventional study where you're taking a drug, for example, or using a supplement or changing a lifestyle, you want to know that it's working. You don't want to have to wait 6 weeks to know it's working or make it cost a fortune to do so.
Okay, so regarding the interventions, there is this what would you say, a logical way of questioning the validity of, I do an intervention, my biological age gets better, because could it be just just kind of analogous to cleaning up a crime scene, right? Something bad already happened, and the intervention only cleans up the crime scene, so it makes the biological aging clock look better, but the underlying biology that does not change, or not to that extent. So I've been thinking about this, and I don't know the answer. I'm wondering if you've been thinking about this, or do you even understand what I'm saying?
I understand the point, and one of the key factors with the 10 CPG site clock is that it hypermethylates with time. All 10 sites hypermethylate with time, and we all start at a certain level of methylation. So our 11-year-old participant, for example, had a certain level of methylation, which was far lower than our oldest people, right? And we've also had people die who've been tested, right? We've had people who've had cancer, people who've had other diseases, and their methylation markers went up. So they actually started to go up faster, accelerated, right? You're right, something bad could have happened, and that is true. So you could be making up for a bad intervention. But say you had the flu or a really bad cold or some sort of virus, and then you did the test, it could come back negative. And then by the time the cold's finished and you do another test, it might come back better than what it was. But it will never be, what's the word? So it will, if say, for example, you did a test now, right? And it came back 10 years older than what you are. And by the time of the test, you were super stressed, you hadn't slept, you had a really bad flu, your leg was injured, you were bleeding a lot, you basically were dead, right? You did the test and it came back bad. And then within a few weeks, all those things disappeared and you felt great. And then did another test, it'll probably come back better, because one of the sites that we look at is associated with more acute change, right? Immune related change. It would come back better, but it probably wouldn't be below your actual biological age at that point. You would have to have a bit more time your chronological age. You would have to spend a bit more time to try and reduce that age back down, if that makes sense. Because it's very hard to bring the trend down on the clock if you're already at your chronological age, because it hypermethylates the time.
2 questions. In theory, with some, I don't know, like epigenetic CRISPR, can't I like precision methylate or the opposite of that, these specific CPG sites, and let's assume I can like program it properly, then would those changes, like I make myself on an epigenetic level look like 18 years old, like, right? Would that actually, like, how much would that actually matter for me,
So that's really interesting, because that way you're talking about correlation and causation, right? Are you saying, are the sites correlating with time, or are they causing aging? Right now, we know that some of the sites are what are called passengers of time. So they are just purely markers. The genes that they sit on and the genes that they affect, they don't really, well, what we can find out so far, their impact on health itself and wellness and well-being is actually quite low. But they're just passengers of time. They either hypomethylate or hypermethylate with time. And those sites are normally in elastic net regression weighted higher, because they correlate better with aging. So if you want a clock that correlates with aging, well, happy days, I'll weight those higher. Now, some sites, they do change with time, but they change acutely with other issues. So they change with disease patterns. They change with, even from a genotyping level. So there's a study, a preprint on SSRN that we did, and we looked at cognitive genotyping as well. We looked at people with the APOE4 variances against people who weren't carriers of APOE4. And there was distinct epigenetic patterns. These people didn't have dementia. I think some did, and some had subjective memory loss but weren't diagnosed yet. But they had distinct epigenetic patterns already. Now, we can't do anything about the APOE4, but what if we could do something about the epigenetic pattern of people with that? Then you think, is it because these genes are methylated differently that the risk of something like dementia is high? Because they haven't got dementia yet, but the pattern is different. I mean, no, APOE4 is related to Alzheimer's. And that's a really powerful thought. And obviously there's no study yet which has done what you've, said and changed them and seeing if it's changed the outcome. But on a study like that, you could say that changing the methylation signature might reduce the risk of the condition, because it might be the epigenetic signature that's leading to the condition. We can't do anything about the APOE4 itself. And it's the same with aging. A lot of the aging sites are passengers of age, but some of the sites are also related to age in some way, like some disease pattern. It could be dementia, it could be cancer.
I see. So it's neither. It's not a binary answer, right? Like there are sites, those are like passengers, and those are like actually causes.
Mm-hmm.
Okay, so you mentioned that you actually have some supplements. Those are like, according to your data set, reversing these epigenetic patterns. Which are these? Tell us the secret.
Okay, so I mean, there's staple supplements that most people should probably think about taking.
Oh yeah.
Vitamin D3 is a big one. Everyone knows about it now, but people should have been taking it for a long time, especially if you live in countries which you don't get a lot of sunlight. And a lot of us don't get much sunlight now anyway, because we're always indoors on our computers, etc. Right? So vitamin D3, I would say, is universally recommended, I think, and it probably should be. And we have seen people with low vitamin D levels also have accelerated aging. So that's a big one. Other supplements that we've seen positive correlations with is something called lycopene. Now, lycopene is found in tomatoes. In fact, the red pigment, I think, in tomatoes. And we've seen that people with high tomato-based diets also do have, over a long period of time, have a reduced biological age. So that could be something people should consider. It may be lycopene. Now, you do have other staples like omega-3, magnesium, and zinc. These are all powerful supplements, especially people with poor diets. Then you want to look at those genotyping results. If you have got the MTHFR variant, maybe methylfolate is beneficial. Actually, if you were going to buy a B vitamin in general, you should just get a one which has all the bioactive versions of those B vitamins. That's something that people don't think about when they buy a B complex. They just buy the ones which is cheaper, but they actually have synthetic versions or poorer bioavailable versions, and some people can't use those. So if you don't want to do a test at all, forget doing a DNA test or forget doing an epigenetic test, just buy a B supplement which has the bioavailable forms in. That makes sense, because if you have got it, you will absorb it. If you haven't got it, you'll still absorb it. So happy days. More experimental type supplements like alpha GPC, for example, have been shown benefits to our memory age over a long period of time. It's a good source of choline, but choline itself isn't going to work. Creatine monohydrate has shown great benefits as well. We've actually got a study on creatine monohydrate.
Doses as well? Dosages?
Yeah, so there are different doses to different people with what want to do different things, and that's something that we're actually going to look at for MuhDo Fight Hub, is that we're going to look at different dose ranges and an algorithm for those athletes so they're getting the correct amount. Now, creatine monohydrate is really great for multiple things, but one of those is obviously the muscle ability of creatine monohydrate, increasing energy, doing more reps, etc., etc. But long-term creatine monohydrate usage is linked to epigenetic change. There's an epigenetic signature in athletes who take creatine monohydrate. Now, most athletes taking it at 3 grams a day or more. 5 grams a day seems to be a kind of average sweet spot. Some athletes are doing 10 grams a day, and some are actually going much higher to around 15 to 20 grams a day. We think, and probably the truth, is that body weight will play a big impact on the dosage that you have. So if you are 100 kilos, you might be looking at around the 10 grams a day mark will probably be better for you. Now, up to 20 grams a day, there was some diminishing returns at that point. So, if you don't want to spend all the money on creatine, at around 20 grams, there was some diminishing returns. The epigenetic patterns didn't change that much, and I don't think performance alters that much at that point. So 10 to 15 grams might be the upper limit, but it could be a case for pulsing creatine as well, not just taking it every single day. There could be a case for pulsing it, not only for financial benefits but also for health benefits and also for athletic benefits.
Bro Science was right.
Hey, yeah, I mean, bro science can be right, though. Bro science can be right. Because normally with bro science, people do something and they say, this works, I'm going to keep doing it. There's no paper what said it works. There's no academic institution that said, you know what, I'm going to do a study on this. Or 20 years later, they come out and say, oh, yeah, it does work. The bro who's been doing it in the gym for, 20 years up to that point and said, I'm vindicated, I'm right. Bro science works because it's done in reality, right? It's done in real time. And that's one of the issues with always relying on studies, because a study takes a hell of a long time. A hell of a long time. Not only does it need participants, it needs to go through ethics, it needs to be written up, it needs to go through boards, then it needs to be published, that takes ages. All this stuff has to happen. So a study can take a long time. And sometimes it's better to just say, if it works, it works for you.
If you want to be Mr. Olympia, don't ask me for scientific paper every single thing that I'm giving you.
Yeah, exactly. It's a combination of both, right? Combination of science and it's a combination of knowing what works.
Right. So what's your involvement in MuhDo? Are you the one who like funded the whole thing, or you teamed up with other people, or how did it start?
Yeah, so for me, like it was formed out of an interest in this field. So I actually work for the NHS in England as well. So I do 2 jobs. And this was more like a hobby for me about 10, 12 years ago. My first degree that I did was in sports therapy. So I've always been into athletic enhancement. I've always been into injury support. And there was a company at the time called MuhDoAge. I don't know if they're still going, but they were based out in Estonia. And they wanted to do DNA analysis on athletes, basically, like a fitness-based panel. So I got involved in that from the injury side a little bit, and from the sports performance side of it. And I looked at the genotypes that are associated with sporting prowess and with injury risk. So, you have your popular ones like ACTN3, you have MSTN, you have ACE. These genes are, they're everywhere now. And I basically helped write the algorithms for that. And I helped write the kind of recommendations that you might want to, come from that, like training programs and rehab care, etc. After I did that for a bit, MuhDo started up a couple of years after. And it was a bunch of guys who weren't in the field of genetics per se, but there was a couple of genetics guys. There was a lady in epigenetics at the time. And they all got together and wanted to form this company. And obviously, because I was already doing it, they kind of got me from there. And I started doing the data analysis of that kind of stuff. So the data came in, I started to look at it and then create algorithms from that. I've done other degrees since then, etc. And obviously, I've published papers with different universities since then. But that's basically how it started for me. I basically do all the data analysis. I help create the algorithms. And, I'm interested. My main interest has always been in the athletic fields and, sporting fields. But then that carry over into health and wellness is also really key for me. They're hand in hand in a way. And they're hand in hand, but they're also counterintuitive, which sounds weird. Professional sport and peak performance doesn't correlate well to a good biological age. Actually, the opposite. When we look at the MuhDo Fight Hub guys, right, they are at their peak performance levels, but their biological ages are rubbish. they all have accelerated ages, and it's mainly because of the stresses that are being put on their body. They're training to that really high level, and that's why it's good to try and make these unique algorithms which suit their needs. Can we predict when they might get injured? Can we help them get to peak performance when they need to for a fight? And then that can be carried over into other sports as well, like the Olympics, athletes in soccer and rugby, etc. So I'm really keen on tailoring these algorithms to meet the needs of the of a certain group. And with MuhDo itself, it's obviously that longevity model or that health and wellness model, keeping people alive, but also keeping people well.
Oh, that's very interesting what you just said, because so I'm personally interested in longevity as a sport, which is starting to emerge right now. And well, let's say you want to be healthy, then you go play football once a week, right? Fine. But then you want to be a football player, you want to be David Beckham. Now you are not playing football once a week, you are playing football every day, all the hours, even when you're sleeping, you're dreaming about football, right? Like that's how much you're specializing on it. So that is obviously not healthy. But there is no such a problem with longevity. People who are aiming for longevity and competing against each other on these biological aging clocks, assuming the biological aging clocks are
Accurate.
accurate, yes, but also there is this thingy phenomena that I just said about PhenoAge, right? That the lower glucose you go, the better you get, even though there is like a point where the lower you go, you shouldn't. So anyway, it can hijack your motivational system, but assuming the yeah, accurate. That's right word. It took time for me. Uh, oh well, don't we have a sport where like we don't have these perverse incentives? You know, like how wonderful is that?
Yeah, I mean, the issue with longevity is so I like to look at our life as a candle. Okay, so everyone's lifespan is a candle, and the flame represents like a vitality. Now you can make that really bright. You can have super strength in the gym. You could be a professional athlete. You could look amazing, feel amazing, basically making the vitality on the candle, the flame, really bright. But by doing so, you might be burning the candle out faster. Now, for some people, that might be worth it. But for some people, doing that, let's take a good example of someone like a professional bodybuilder, you know, Mr. Olympia. These guys are burning that candle with a flamethrower. Not only are they training ridiculously hard, but they're taking drugs which are putting their health at risk. But by putting their health at risk, their muscles are all bulging out. They look amazing, no body fat. You know, they have that aesthetics, they have that look, right? With a lot of, you know, young guys these days following that. They want to be like that. So, and a lot of young guys now, they say that when they're in the gym, and I'm happy to take drugs at the age of 16, 18, because they want that look and they don't care that it might take 10 years off their life. They want that candle to burn bright. And that's probably caused by social media, you know, because they want their Instagram following to be higher, etc., etc. So they make that candle burn bright. On the opposite side of that, you can have the opposite. You can try and make that flame as small as possible. You know, you want to have, you know, you have no wellness basically anymore because you've isolated yourself from the world and your candle stays long. You know, your candle's no longer burning out. But what's the point? You're not living. You're just staying alive at that point, you know? So there has to be a line between the two. So you could take longevity as a sport to its extreme and it's still negative. Anything to the extreme is negative. Don't think that it's great. We want people to eat healthy, we want people to exercise, we want people to take the supplements that they need. But don't take longevity to the point where you've just spent the last 110 years of your life trying to live to 110.
I see. Yeah, so if you take something like the Needham pace, then the extreme is that you cryopreserve yourself, right? So you're not aging, your phase of
Yeah, you're
aging is
pseudo.
zero,
Not
right?
only that, what's the point? In hope that one day people are going to be able to unfreeze you and then you'll be, you know, happy days alive again. You know,
Well,
you have to live. You have to live.
what a more practical example would be that I think there is this trend that I want to slow down my metabolism as much as I can. Uh, you know what I'm
Yeah.
talking about?
Mhm.
Yeah. So this seems to me a very similar longevity objective that makes the candle not burn
Not
very
and
bright.
another thing that I see is people won't go to events. So they won't go to like an event because of people who could be ill. They could be coughing. They could be around you, giving you pathogens, right? And that's going to activate your immune system, and that's going to make your candle burn a little bit. You don't want that. So I won't go to events anymore. So now you've isolated yourself socially as well to try and live longer. So you're no longer living your life. You're just focused on that one thing. The same with any sport. If you take the sport to the extreme, it's negative. You might live longer, but again, there was no point of all of it. You still can't win, if that makes sense. You're not going to win in this sport, right? If I look at our methylation clocks, they still hypermethylate. You might be able to make it go slower. You might be able to stop it for a little bit, but it will hypermethylate eventually. Every single person who was older in our cohort had a higher methylation than those that were younger, all of them. It's 100% accurate in that regard. You will not stop it. You will not slow it down for long enough that you will just live forever. It always goes up, just like time. So people need to think about what they want to do with longevity. You want to be healthy and live well. You want to enjoy your life and live as long as you can enjoying your life. And that's the key to longevity, in my opinion.
You see, there is this. Well, I just came up with the longevity paradox, which is the notion that while you're young, you perceive time to go much slower, right?
Yeah.
And as you get old, it just flies by and you're already in the 80s. But why is that? And one of the leading philosophical theory behind it is the experiences that you're experiencing much less. As you're young, you're like everything is new, novelty here and there, everywhere. When you're old, it is not, novelty is not even a thing anymore because you're just familiar with everything, you've seen everything. Or you can think about people who go into coma and they wake up, they perceive it like almost like instantaneous, like, oh, I just got into coma yesterday, even though it was 1 year ago.
Yeah.
And I woke up. The point is that the current zeitgeist of longevity is very strong on habits and routines, right? And what habits and routines do is that it fakes our experience. We are not experiencing things that much anymore because we just go into a robot mode and just do whatever we do every day over and over again.
Yep.
Right.
And what happens is that you get into well, it's actually something Brian Johnson said, right? One of the most famous people who try to live longer is that every day I want to live till the next day, till eventually you don't die, right? That's what he basically stated in, I think, the Netflix documentary. I quite like the guy. I think he does some cool things, all the experiments and whatnot. It's quite cool. As a case study, it's pretty cool. So yeah, I quite like that. But if every day all I'm doing is trying not to die, I'm really boring. I'm so boring that eventually I'm going to die. Everyone knows that. But so all I've said and all I have on my gravestone is that every day he didn't want to die, but today he did. That's basically the entire lifespan of someone who thinks that way. Now not everyone's going to have the money to be able to do all the cool experiments and stuff that he does. So if people in who want to follow that kind of routine, they get stuck, like you say, doing the same old habits. They wake up at the same time. They might do a few stretches, a bit of yoga. They'll drink some horrific shake. Then they'll have a set meal for breakfast, probably a set meal for lunch, a set meal for dinner, maybe 6 meals. Who knows? They might be doing intermittent fasting on that day. I don't know, but that's it. Everything's set out nicely. There's no spontaneity. There's no socializing because they don't want to get ill. They lose out on a lot. You're losing out on a hell of a lot to try and stop something that no one's ever stopped.
That's right. Well, we don't have to argue that the opposite direction is problematic as well, right?
Yeah.
Maybe even more problematic.
Yeah. Yeah.
We talked so much about clocks, but you're just an expert on this, so I have to ask all my clock questions to you. And my can you tell me your expert opinions and an overview of the clocks, of the commercially available clocks, right? And your expert opinions on them.
Yeah, I think most of the clocks which are commercially available right now, and you have TrueAge, you GrimAge, the Horvath stuff. I think there are some good clocks out there, and I wouldn't bash on any of them, to be honest. They all have their own place, and they're all good, and they could all be used. You have the MuhDo clock, and we're actually releasing a new clock with a company called Umu, which is Arabic, sorry, for mother. And so the Umu biological age clock was actually trained on females only. So we used the female only cohort to make the clock. And the correlation with aging was higher in females than it was in males. When you apply it to males, it correlated well with males. I think it was an R2 of about 0.77. And in females, it was an R2 of about 0.89. So really high from saliva. And this was a 41 CPG clock. And what's really cool about it is that some of the genes that were actually pulled in from the female only cohort analysis were associated with things like fertility. They were associated with hormones. So it could be a really good way for females to better understand their actual biological clock when it comes to having children, because that's something that females always talk about, oh, my biological clock is moving forward when they talk about having kids. So this is a really scientific way to analyze that. So we were hoping to launch that with that company called Umu, which will be focused on, the motherhood and pregnancy and a child as well, really helping people get through those stages, and obviously looking at things like MTHFR, rather having folic acid, have methylfolate, etc. That's the base genotyping stuff. But that epigenetic stuff, which is really unique, that's where we aim to go with that. My aim, as I've mentioned, is that the biological clocks which are out there, they're all good, really. And the MuhDo clock's good because we mentioned it's going to be cost effective, and in the future it's going to have a really quick turnaround, and it's trained on saliva, which is nice. So you're getting the best for that when you're doing a saliva test, and you could do multiple with the same money it would cost one of the other clocks. But my aim is actually to have epigenetic tests or DNA methylation tests, which are more associated with a disease or pathology, or associated with traits, or associated with like the injury risk factors, the overtraining, because I think that's actually what people really want to know about. When people talk about aging, they are worried about aging, but they're always worried more about something associated with aging, right? They're worried about things like wrinkles or osteoarthritis, losing their eyesight, losing their hearing, getting dementia, getting cancer. They're worried about something that associates with aging, not so much aging itself. I'm not too concerned about tomorrow. I'm not concerned about tomorrow at the time. I've lost a day of my life by being here for a day. That doesn't really concern me, but am I a day closer to a disease? Am I a day closer to not being able to do the things that I want to do? Am I a day closer to osteoarthritis, for example, or dementia? That's what I'm more concerned about. So I think when it comes to the clocks, we start to move away from just correlation with age. We start to move more into traits, diseases, and with more functional testing, I suppose.
Yeah, definitely. You see, I started interviewing people who are doing some work on biological aging clocks, and these are the best, most fascinating interviews I'm having. And you didn't disappoint here either. What's one thing you strongly believe to be the case, but very few people agree with you on?
That's a difficult one. That is a difficult one. What do I strongly believe to be the case? I will go with a sporting one. I'll go with an athletic one. I strongly believe that our bodies, now a lot of people do believe this, so they agree with it to some extent. Our bodies respond to stresses on the body. It responds to, when you train, when you lift weights, for example, our bodies respond to that. What I believe, though, is that you need to push it. You need to go to failure a lot of the time when you train, because that's what gives you the most potential for growth and gains, but it also increases your risk of injury. So when it comes to training, I'm more of the mindset of failure training, really pushing it. And that might be the case that you have a partner and they're helping you doing forced reps. You might be doing some negatives, drop sets, for example. I believe in that method of training is the best method of training to hit your highest potential at the risk of injury. And that's why I think some people would disagree with it, because they are more likely to say, well, a programmed approach would be superior.
I see. Yeah, you see, I just hired a personal trainer for the first time in my life, and he's not doing the programmed approach. He's doing 1 hour of death. Like, I'm dying for 1 hour, and but it's not like what I was doing by myself, like, okay, let's put more weight and then do the weights. No, nothing like that. It's just death
1 hour
for
death.
1 hour failure. Failure
1 hour
from the
death.
first.
Well, I guess if you don't die, then you'd be better off for it.
Yeah. Well, Chris, that was wonderful. Thank you very much for coming.
Yeah, no, perfect.